Great. Well, I'm having trouble with my Zoom screen right now, but I know I've just admitted Dr. Hansen, so welcome. And I have the pleasure of introducing Dr. Hansen, who is author of Smokescreen, Debunking Wildfire Myths to Save Our Forests and Our Climate. Dr. Hansen is director and principal ecologist of the John Muir Project, which he co-founded in 1996. He first became involved in national forest protection after hiking the 2,700-mile length of the Pacific Crest Trail from Mexico to Canada with his older brother in 1989. Welcome, Dr. Hansen. We're just delighted to have you with us today. The floor is yours.
Thank you all. Thanks for the opportunity to talk to you today about forests and wildfire and climate change. I'm going to share my screen here. Oh, I see it says host disabled participant screen sharing.
Okay, give me a minute here.
All right.
Okay, let me go to you and brother.
Somebody's got a big clock.
I know. I am making you a co-host since I can't seem to get the screen share. Huh.
That should work.
That should. Let's
Yeah.
see. We are having our Zoom challenges today. For sure. Is it working for you, Dr. Hansen?
Let's see. I think so.
There. Oh, yes. There we go.
I think so. So, can everybody see my screen?
Yes. Yes.
Okay, good. So I will stop my video just in case there's a bandwidth issue, but it should be fine. Just while I'm talking here. All right. So again, thanks all for inviting me to come talk to you today. I'm going to be talking about some of the key themes in my new book, Smokescreen: Debunking Wildfire Myths to Save Our Forests and Our Climate. And there's the cover of the book. First off, though, I'm going to talk a little bit about how I got involved in this issue. And thanks for the introduction. As was mentioned, I hiked the Pacific Crest Trail from Mexico to Canada with my older brother in 1989. That's me on the right there. You know, at the time, I was not politically involved. I had no knowledge of the difference between national forests and national parks, for example. And you know, by the time we got to the northern Sierra Nevada, we began to see all the logging on public lands on national forests. And then we saw even more of it as we got into national forests of Oregon and Washington and got closer to Canada. And it made a big impression on me, you know, just the sense of loss and devastation of wild places. It was something I had no idea was happening on public lands. So when I got back, I sort of changed career direction, and I have been involved in forest conservation ever since, ultimately going back to school and getting my PhD in ecology. And I've been researching forest and fire ecology issues and climate change for about 20 years now. This is my brother and I, about 3 days from the Canadian border, looking much thinner and much more tired and not nearly as clean shaven. So before we talk about some of the key myths about forests, fire, and climate, I just want to briefly mention something that is, you know, deeply important and is certainly related, which is, you know, how best to protect communities from wildland fire. And you know, this is something that's an issue in various ways all across the country, not just in the West. And the bottom line is this: is that what the science is telling us is that the only effective way to protect homes from fire is to focus on the homes themselves what we call home hardening, and to do defensible space pruning within 100 feet of homes, and especially that first 30 feet. That's the most important. And it doesn't mean cutting down mature trees on your property. You actually don't want to do that. You want the shade from those trees. But what you do want to do are things like fire-resistant roofing, or at a minimum, if you have composition roof, which is pretty decent, sweep the pine needles and leaves off the roof every fire season. Replace those old exterior vents with modern ember-proof vents that have a fine wire mesh, so the embers that are driven by the winds in advance of the flames can't get pushed into or sucked into an attic vent, for example. And simple things like rain gutter guards to keep the dry leaves and pine needles from accumulating next to the roof. So simple things can make a huge difference in terms of protecting the home from
Recording
wildland
in
fire.
progress.
Now, the other thing, of course, is defensible space, and that it really is about very light touch pruning within, especially the first 30 feet, but out to as much as 100 feet from individual homes. It's not about a big zone around a community. It's about what happens around each individual house. And it's really about removing lower limbs on mature trees, but leaving those trees standing. It's about removing dry grasses next to the house, making sure that you prevent accumulations of leaves and pine needles and twigs next to the house. Simple things like that. Make sure you don't have shrubs right next to the wall of the house. Simple things can make the difference between a home surviving or not if a wildland fire is occurring. And interestingly, beyond 100 feet from homes, there is no additional benefit to vegetation management. So we hear a lot about what people call the all of the above approach. Like, well, I say, yes, well, we'll do some home hardening, we'll do some defensible space, we'll allocate, some public resources to those purposes, but we're also going to do a bunch of vegetation management out in the wildlands. Now, mostly what that means is logging, and that's where the vast majority of money is going. Problem is that's not protecting homes, and as I'll talk about more, it's actually putting people at greater risk. Because the reality is that when that's the approach, communities have a false sense of security. They believe, because they've been told, that those logging projects out in the wildlands, which are often euphemistically packaged and described as fuel reduction and fuel breaks, that somehow that's going to protect them from a fire, that it'll stop the fire from reaching the town. And people don't feel as compelled to do the defensible space pruning or put those ember-proof vents on their exterior vents. They don't feel as compelled to sweep those pine needles off the roof. And we're seeing the tragic consequences of that. Not only are these logged areas that are where the logging is done euphemistically under the heading of fuel reduction, not only are they not stopping fires, the fires are often burning fastest and hottest through these areas. And we saw that tragically in Northern California in 2018 in the Camp Fire, or in the first 6 hours of that fire, it burned through heavily logged areas that where the logging had happened in the previous decade, both post-fire logging and commercial thinning. And that's where the fire burned the fastest and most intensely before reaching the town. We're seeing the same thing in 2021 with, for example, the Caldor fire in the Sierra Nevada. Those orange and yellow areas, those are previous, the orange areas are previous logging. And you can see logging was extensive. Most of that's commercial thinning. Fire just burned right through that and burned down the community of Grizzly Flats on the western side of the fire there. Same thing in the Dixie Fire, nearly 1 million acre fire this year in the northern Sierra Nevada, technically the Southern Cascades, and Northern California. And you can see again, those yellow, those orange areas are previous logging. A lot of that's commercial thinning. And the fire swept through thousands and thousands of acres of that very rapidly and burned down the town of Greenville. This is almost entirely preventable. What we are finding in example after example is if the home hardening is done, if the defensible space work is done, if communities get serious about this, and if, in particular, if assistance is provided to communities that need it, that we're oftentimes seeing over 99% home survival, and everyone is able to evacuate safely when that's the priority, even during a very fast-moving, intense wildfire. So the focus should not be on logging in the wildlands under the guise of fuel reduction or fuel breaks. That's not working. All that's doing is putting a lot of carbon in the atmosphere, and it's often making the fires burn hotter and faster toward the towns. So I'm going to shift here and now and just talk a little bit about the key issue here that's facing all of us, which is the climate crisis. And we know, of course, that we have to move beyond fossil fuels to overcome the climate crisis. But what the scientific community is telling us nationally and globally is that that's not enough. Because once we put all the excess CO2 up there through human activities, it stays up there for a very, very long time. So we have to not make it worse, certainly, but we also have to draw down and reduce those atmospheric carbon levels because they're way too high right now, 417 parts per million of CO2 equivalents. The only effective way to do that, an environmentally beneficial way to do that, is what we call nature-based climate solutions. And true nature-based climate solutions involve protecting natural ecosystems, especially forests, so they can pull more CO2 out of the atmosphere because forests absorb CO2 and incorporate it into the growing wood. There was a letter from over 200 scientists, climate scientists and ecologists to Congress last year. The link's at the bottom of the page there, and it's on the John Muir Project website on our blog page. And basically, we told Congress exactly this. We need to start shifting away from logging. It's not going to happen overnight, but we need to begin a shift and start reducing our wood consumption and start protecting more forests to overcome the climate crisis. Now, if we do that, forest protection can be as much as half of our needed climate change mitigation. This is a huge part of climate change mitigation. And the US can play a huge role in being a global leader in this regard. But there are some harmful myths that are getting in the way of the necessary progress in terms of climate solutions. And so I'm going to talk about some of those myths that are perpetuating current logging practices and the current damaging and ecologically harmful and climate harming levels of logging. So the first one is what I call the overgrown forest myth. And this is the idea that because of fire suppression, because of environmental laws and regulations, that somehow the forests are overgrown, they have too much carbon in them, they have too much biomass, and that's why fires are burning much more intensely. The logging industry is telling the public this all the time. So is the US Forest Service, which I'm sure, as you all know, the US Forest Service is in the commercial logging business. One of the main things they do is sell public trees to private logging corporations and keep the revenue. And a lot of ecologists, including myself, think that that needs to change, that that's an outdated policy, and we need new laws to get the Forest Service out of the logging business and protect our national forests. But under existing laws, they still engage in commercial logging. And so both from the standpoint of the logging industry and the Forest Service, this political narrative is very, very useful economically, because what they're saying is we need to roll back more environmental laws and increase public subsidies for logging and increase logging levels, supposedly so we can reduce the density of our forests, and that somehow will curb fires. Now, that is not consistent with the science, and I'm going to explain why. First of all, in every forested region of the US, current levels of forest carbon storage are substantially lower than the biological potential of those forests. Now, most of that is due to many decades of carbon removal from logging. So we actually have less carbon in our forests. They have less biomass in them in most cases than they had historically, and in many cases, far less. Now, the good news is that means there's huge climate change mitigation potential if we protect our forests and reduce logging, and in many places, especially public lands, stop logging and allow our forests to absorb more carbon from the atmosphere and increase their carbon storage. Now, many studies have looked at this question about, well, what happens in places where you do have denser forest conditions, where you do have a lot more biomass? Does that mean that the forests will burn more intensely? It turns out the answer is no. In fact, it's typically the opposite. Denser forests, forests with more biomass, forests that are more mature and older and have more canopy cover, typically they have lower fire intensity, all other things being equal. Certainly they can burn at low, moderate, or high intensity fire in any given area, depending on what the weather's doing. But on average, they tend to have lower fire intensity. And that's what this graph shows. This is from Zalden, done 2018. And this just shows that as biomass goes up in a stand of forest, that line above it is fire intensity, and it tends to go down. Similar results in other studies that I cite there in the lower left of the image. Lots of research has confirmed the same thing. And in fact, interestingly, forests that have not burned in a very long time do not burn more intensely. In fact, they often burn less intensely. And this is just one of many studies finding this. I found the same thing in my results in studies of the Sierra Nevada. And those black bars on the bottom are high intensity fire, and the gray is moderate, and the light gray is low intensity. And what you can see is the forests that haven't burned in over 75 years, TSF means time since fire, those forests had the lowest levels of high intensity fire. In my research, I found it was basically similar levels, but it certainly wasn't higher. And so that's really where the debate is. Is it similar or lower levels of high intensity in the forests that haven't burned in 75 years or a century or more? And interestingly, they're burning mostly at low and moderate intensity. Even the biggest fires, mostly low and moderate. So one of the key things that is emerging from the data is the fact that, you know, one of the key, the primary fallacies of the overgrown forests myth is that fires are driven mostly by forest density, which is not true. Fires are driven mostly by weather and climate factors, and therefore climate change is a significant influence. My colleagues and I did the largest scientific analysis ever done on this question. We looked at 3 decades of data, fire data across the entire Western US, and we found that weather and climate variables were dominant, but logging was a key secondary factor, but not in the way most people think. In fact, what we found is forests with the fewest environmental protections and the most logging had the highest fire intensities. In fact, basically, the more trees you remove from the forest, the hotter and faster the fires tend to burn, oftentimes toward communities. And that's a dangerous situation. So logging, including what people euphemistically call thinning, is not stopping fires, nor is it in most cases making them burn significantly less intensely. It's often having the opposite result. These are results from another study that just found that depending on different scenarios, thinning often increases fire intensity, and those are the bars going to the right. In fact, more often than not, thinning results in higher fire intensity, not low. And there's a lot of variables that determine how a fire burns in any one particular location. A lot of it has to do with weather, gusts of wind and temperature and relative humidity. But bottom line is, this is not a reliable way to reduce fire intensity as many folks in the logging industry would have us believe. Now, interestingly, it's also not true that forests are burning more intensely because of dead trees. We hear that a lot, you know, that it's because of all the dead wood, the dead trees and the down logs out in the forest. The most comprehensive scientific studies on this question have found that forests with more dead trees burn at equal and sometimes lower intensities than forests with fewer or no dead trees. Now, how can this all be? It really comes down to microclimate. A denser forest, a forest with more biomass, has higher canopy cover. And a forest with higher canopy cover has more cooling shade from that canopy cover. And that means the forest floor stays more shaded, more cool, more moist during fire season. In addition, a denser forest with more trees acts as a windbreak against the gusts of wind that drive the flames. And whereas a more open forest doesn't have that same windbreak effect, and winds can sweep through those areas faster, which often means higher fire intensity. And so when a denser forest is reduced in its density through logging, including thinning, what happens is you have lower canopy cover and you get hotter, drier, windier conditions. In addition, logging leaves behind a lot of combustible slash debris and spreads invasive combustible grasses, which will also make things more conducive to fire. So it's really not about fires are not burning more intensely because the forests are too dense, because there's too many dead trees, or because they haven't burned in too long. That's not really what's going on. In fact, when forests are logged, that's when they tend to burn more intensely. But again, if you have those hot, dry, windy conditions, you're going to have a faster moving fire that's going to tend to burn a little bit more intensely no matter what, because weather is dominant. The other one I'm going to talk about is what I call the catastrophic wildfire myth. And this basically is the idea, and I'm sure you've heard various forms of this narrative, the idea that if fire burns in a forest, that it destroys the forest, or at least it destroys the forest in places where it burns hot and kills most or all the trees. And that's also not true. A lot of people used to believe that, but we have hundreds of scientific studies on this now, telling us very strongly that the opposite is true. In fact, in forests, first thing that is important to realize is that even in the largest fires, they burn mostly at low and moderate intensity. And whenever the Forest Service puts out these fire severity maps, they always put high severity fire in red, and it really draws the eye. In this image, this is the Rim Fire of 2013. It was a 257,000 acre fire. And those red areas look really, really big, but they're actually only 19.9% of the total fire. The fire was 80% low and moderate intensity, which are those light and dark green and yellow areas. And those are areas where most of the trees survive, certainly most of the mature trees, and even in many cases, most of the small trees. It's in those red areas where most trees are killed. And but again, it's a minor portion of the fire. This is the Wallow Fire of 2011 in Arizona, 565,000 acre fire, only 9% high intensity, those red areas, over 90% low and moderate. And so again, even the biggest fires, doesn't matter how big they are, they're still mostly low and moderate intensity in almost every case. So what does it mean in these places that really do burn at high intensity, that 9% or that 12% or 20% or whatever it is in a given fire? Well, historically, before fire suppression, high intensity fire typically comprised 20 to 35% of any given fire on average, even in the more frequent fire forest types like mixed conifer and ponderosa pine. In less frequent forest types, like many in Western Washington and Western Oregon, the fires would not burn nearly as frequently. And when they would burn mostly at high intensity. That's the natural fire regime. They just wouldn't do that nearly as often. It's a very infrequent fire regime. But in the frequent fire forest types, like the Eastern Cascades or Eastern Washington, Eastern Oregon, like the Blue Mountains, for example, this was common historically. If a fire would burn, 20 to 35% would be high intensity. And this is just a map that was created by a group of scientists in the late 1800s in the northern Sierra Nevada. And those white polygons, those cross-hatched areas, those are large high-intensity fire patches that happened sometime between 1800 and 1890. And many of them are many thousands of acres in size. This was done by early US Geological Survey researchers. And it just shows that, of course, there were lots of low and moderate intensity areas too, but in certain places and not that infrequently, there were also large high-intensity fire patches. And most of these were from large drought years, where you had hot, dry, windy conditions in combination with big drought years, which naturally happen several times per century. And this is a quote, just one of the many quotes in the report where that map came from these US Geological Survey researchers. And it just describes this mix of habitat conditions, dense old forest next to areas that burned at high intensity, where you have these standing fire-killed trees, what we call snags. Dense regenerating forest, chaparral growing in after the fire. Years ago, people thought this must be a bad thing. It turns out it's exactly the opposite. These areas that burn at high intensity, they create what we call snag forest habitat, more technically known as complex early seral forest. And complex early seral forest habitat, also known as snag forest habitat, is incredibly rich ecologically. This picture here is an area of naturally regenerating snag forest habitat in the northern Sierra Nevada. I took this picture at 12 years post-fire, and you can just see all the wonderful natural forest regrowth, conifers, pines, fir, cedar, shrubs, dogwood, willow, and of course the standing snags and the down logs. All of this is incredibly important to wildlife. These snag forests, it turns out, are comparable to old growth forest in terms of wildlife abundance and diversity. These areas are ecological treasures. We used to think they were destroyed. We used to think they wouldn't naturally regenerate. Now we know better. They regenerate abundantly, and there are numerous wildlife species, many, many dozens, that depend on either the snags or the natural forest regrowth, or both. And I'll just talk briefly about a couple of those. In the top of this image is the black-backed woodpecker. I've been studying this species for about 20 years now. And black-backed woodpeckers strongly depend on high-intensity fire patches, snag forest habitat, because they eat the larvae of wood-boring beetles that in turn depend on recently fire-killed trees to reproduce. And the black-backed woodpeckers find those larvae underneath the bark, the charred bark of fire-killed trees, and they eat thousands and thousands of them every single year. And they need a lot of fire-killed trees to be able to do that. And fire-killed trees, or dead trees in general, are also softer than live trees, which allows the woodpeckers to excavate nest cavities. They do they excavate 2 to 4, each pair will excavate 2 to 4 each spring, and the female picks the one she likes the best, and that's where they raise their young. And then all the cavities they create but don't use are available to the many, many dozens of other cavity nesting species in the forest that need cavities in trees but cannot create their own, like bluebirds, like nuthatches, like flying squirrels and chipmunks, and many, many other bird and small mammal species. And of course, in many of the species depend on that rich natural regeneration in the understory, the flowering shrubs, the understory plants, the down logs, and shrub nesting birds and small mammals. And in fact, in snag forest habitat, bird abundance, total bird abundance, often and typically goes up with increasing fire intensity. It's often the highest in these high intensity fire patches, so long as they're not subjected to destructive post-fire logging, which basically removes and eliminates all of the benefits that fire provides. And I know a lot of folks are interested in spotted owls, and I am too. I've been studying them for many years. This is a paper that my colleagues and I published 3 years ago. And what we found is that spotted owls, they nest and roost in dense old forests that's either unburned or lightly burned, but they go out of their way to forage in the snag forest habitat because that's where their small mammal prey biomass is the best. Small mammals love the snag forest, and there's a lot more of them there than there are in old forest. And so the spotted owls just get a bonanza there in terms of their diet. But when post-fire logging occurs, it targets that snag forest and it removes their essential foraging grounds, and spotted owl populations plummet after post-fire logging occurs, even if it's as little as 5% in the territory. Now, another key myth, aspect of this myth of catastrophic wildfire is that is this notion that we have that fires are in excess of natural bounds. The reality is that we have less fire now in our forests than we had historically across the country. And this is true in various different forest types. It's true in the West, it's true in the East. We have significantly less fire in our forests now than we had historically. Now, fire has been increasing over the last 40 years. Part of that is climate change. So we are getting closer to historical levels, but we still have less. And so it's important to realize that and to understand that if fire continues to increase, it's not destroying our forests, but it can threaten communities if they're not protected. And that's really where our focus needs to be, keeping people safe by focusing on saving homes and saving lives at the community level. Interestingly, even in high intensity fire patches, only about 3% or less of the tree carbon is actually consumed. People often assume it's 50% or more of the tree carbon. It's actually not. It's a tiny amount, just a superficial outer layer of the bark, small twigs, pine needles, seedlings. That's what gets consumed. Otherwise, the carbon still remains there, even if the trees are killed. And so for that reason, all of the current models vastly overstate carbon emissions from wildfires, and none of them account for the amazing and vigorous post-fire regrowth and all the carbon sequestration that comes from that regrowth. This is just one example here. This is a large high-intensity fire patch in the Rim Fire in the Sierra Nevada. This is me on the right, and globally famous climate scientist, Dr. James Hansen, on the left of the image here. And he and I are trying to stop a large post-fire logging project on a national forest in this area because they're claiming that the forest is not regenerating and that they have to log the forest and artificially plant trees, supposedly in order to recover forest and reforest the area. But here's what it looks like right next door. Same area, same high intensity fire patch, but this is where post-fire logging happened more than 4 years earlier, and tree planting. And because of all the damage from post-fire logging, the soil compaction and all the nutrient removal, when the trees were removed, very little grew. Most of the seedlings they planted just died. And so what they're calling restoration and reforestation is actually deforestation. Here's another example. This is in the middle of the largest high intensity fire patch in the entire southern half of the rimfire. And this is all natural forest regeneration at 8 years post-fire. Wonderful, vigorous regeneration and lots of carbon sequestration. But right next door, where the post-fire logging happened under the guise of fuel reduction and reforestation, is just bare ground and invasive combustible grasses like cheatgrass and slash debris. Trees were planted, most die. That's not true in every case. In some places, the trees don't die, but you don't really have much of a forest there, and you don't have much carbon because most of it was removed by the logging. And you certainly don't have much wildlife habitat in a tree plantation. This, by the way, is natural regeneration in a high-intensity fire patch in a giant sequoia grove. Giant sequoias, it turns out, regenerate very vigorously after high-intensity fire, moderate intensity too. They do not regenerate very well at all after low intensity fire. So many tree species actually depend not just on wildfire, but also fire that burns a little hotter in order to release the seeds from their cones and create that nutrient-rich bed of mineral ash that allows for germination and seedling establishment. So because so little carbon is actually consumed in a forest in a large fire, especially the tree carbon, and because of all the vigorous post-fire regrowth and sequestration, forests become a carbon sink again in a relatively short period of time after fire, in part because of the nutrient cycling and all that forest regrowth. Lots of studies indicate this. Now, all of our forests continue to be a carbon sink at the regional scale. On some private lands, that's not true because logging is so intensive. But they could be much bigger carbon sinks overall if we protected them from logging, if we protected public lands, and if we provided financial incentives to reduce logging levels on private lands. And I believe we need to do that. Also, we should provide public resources to acquire more private forest lands from willing sellers into protected public ownership. Because the reality is that logging is the real carbon bomb, not wildfires. And this is especially true when it comes to biomass logging, which emits even more CO2 than burning coal for equal energy produced. And it's a growing threat in both the Western and Eastern US, where entire whole trees are being removed and sometimes entire stands to be hauled down to biomass facilities and incinerated for energy production, like sticks of coal. This is a really bad idea from a climate change perspective. And this is what that looks like on the ground. This is an area in the rimfire where the snag forest that was regenerating naturally, it was all clear cut, and the young trees that were regrowing were cut, and the snags were cut, all the shrubs as well, and all hauled down to a biomass facility and incinerated for energy production. We call this clear cuts for kilowatts. And it is a climate change nightmare. We need to move away from this and fight any proposals to that would increase subsidies for this. This is an area where commercial thinning occurred, and you can see that some mature trees were left, but most of the biomass was removed here. This is really common, unfortunately. Most commercial thinning operations are not light touch operations. They're pretty intensive commercial logging operations that kill and remove most of the trees and therefore most of the carbon in a given stand, or at least a large percentage of it. In fact, logging in US forests emits 10 times more carbon than fire and native beetles combined. And the reason for that is anytime a tree is removed from the forest through logging, most of the carbon in that tree ends up in the atmosphere almost immediately, because the branches and the tops of the tree, what we call slash debris, comprises 35 to 40% or more of the carbon in that tree. That's incinerated either in the forest or at biomass facilities. And then of the log that's hauled down to the lumber mill, an additional 25% of the initial tree carbon becomes mill residue and does not end up in a lumber product. And that's incinerated as what they call hog fuel at the lumber mills. And that carbon ends up in the atmosphere. And then, of course, you have all the transportation and carbon emissions from that. At the end of the day, the net carbon storage in lumber products is only about 18% of the initial tree. The rest goes into the atmosphere. And that is a real problem. We just cannot afford to do that. So what does it all mean? I'd say, beware of legislation that claims to promote forest health or fuel reduction or restoration through euphemisms for logging, like thinning, and all these terms, frankly, are used as euphemisms for logging, fuel reduction, and forest health. This is just code these days, legislatively and administratively, for logging operations, including logging that removes old trees, large trees, including clear cuts and post-fire clear cutting, and support proposals to increase protection for our forests, including on public lands and especially public lands. And also move away from logging subsidies, just like we're having a conversation about getting away from fossil fuel subsidies. We need to have the same conversation about logging subsidies. So I am going to stop screen sharing there, and I'd be happy to take questions.
Thanks, Dr. Hanson. I see that folks are going to put some questions here in the chat box, and I know Amy's going to help me monitor things as well. So let me scroll down here. Hang on just a second. Well, maybe I could start the ball rolling for folks here. Is one of the things I was most interested in follow up for you is the letter that you sent to Congress in 2020. So kind of what is the status of that letter? What response did you receive? Do Congress people from our state, where did they weigh in on that? What is that response from our legislators? And can we use this information to help educate people within our area here?
Yes, absolutely. It's a really important education tool. Again, you can find the letter on the John Muir Project's website on the blog page. It's a letter from over 200 climate scientists and ecologists that we sent just last year. And the response has been mixed, both for Republicans and Democrats. Some some legislators just don't want to run afoul of the logging industry. And so they have been relatively silent on it. Some are actively doing the wrong thing. These are typically legislators, whether Republican or Democrat, who are taking a lot of campaign contributions from the logging industry. And some have been very supportive, but are outnumbered by the current leadership in both parties, where they're much more aligned with promoting additional subsidies for logging. Right now, unfortunately, the leadership in Congress, both in the Senate and the House, the Democrats and also the Biden administration, are pushing increased subsidies for logging on public and private lands in both the infrastructure bill that came out of the Senate and the reconciliation bill in the House. We need those provisions removed because we cannot afford billions of tons of additional CO2 going into the atmosphere over the next 10 or 15 years if we triple or quadruple logging subsidies. We just can't afford that. And that's what these bills are proposing right now. And so it's really just a big step in the wrong direction. So I think we really need organizations to reach out to their members of the House and also their US senators and also the Biden administration and urge them to get rid of those logging subsidies that are all of them euphemistically packaged as forest health or fuel reduction or fire management. They are not, they're anything but. let's see. Someone asked, where can you get a copy of the letter? Again, it's on the John Muir Project website, but I'll try to grab a link. Sometimes I'm not able to paste links into the chat, but I'm going to try to grab a link for it and put that in the chat right now. So that people just can have a copy of that, because it really is an important letter. I'll do that in just a second here.
So I wanted to state that, Mason County has 615,000 acres. Out of that number, 552,926 acres is called forest land acres. So we've got about 85%. We have a timber industry here. So what you're talking about is basically a sacred cow in this area. And so there are a number of ways that we would try to do away with the logging industry's subsidies, and we would go to our legislature. However, there are so many lobbyists in Washington state. If you go there to Olympia, they are very, very well-paid lobbyists who are pushing back on us. And basically, we're not getting the message out. We don't have a clear message as to what this is doing to our community. I don't know if there's a question in there somewhere.
Well, I think, it's an important comment. First of all, I just put a link to the scientist letter in the chat. I also put a link to my book Smokescreen in the chat. So both of those are there. But in response to the comment, 'cause it's a really important comment, I would say a couple of things. First of all, there's some really important economic research done by the firm Headwaters Economics, based in Montana. A lot of PhD resource economists, top folks, have analyzed this. And what they've found is that rural counties in the West that have higher percentages of protected public lands actually have higher per capita income on average and lower levels of unemployment. And this is really important because certainly, the logging industry, there's a certain number of jobs associated with the logging industry, but there are far, far more jobs associated with protected forests because of the recreation and tourism economy. And of course, that's good for the climate, it's good for biodiversity, and it's also good for local economies. So I think that is important to keep in mind. If folks want to reach out, I'll put my email address in the chat. I can send that report or a link to it. And so people can have that. But I think, the other thing is that, you have to do the best you can, certainly at the state level, even if the logging industry has kind of a grip on certain legislators. But there's also a lot that can be done at the federal level because, a lot of the members of Congress, especially the Democrats, they have a much broader constituency. And I think a lot of them, even the ones that are getting funded by the logging industry, they're very vulnerable politically if that's exposed. And I think there's a pressure point there that can get them to rethink taking that money, and that will basically make them more open to promoting forest protection policies and ending logging subsidies.
Thank you. So here's another.
Oh, sorry. I just wanted to go back the list here. See, Dan Zealous, I see that you had my question is in the chat box, but I don't see the question. So go ahead.
Yeah, I was having trouble copying and pasting. So I just actually managed to type a question. And if you don't mind, and I just click enter. So if you could look at that and then respond to that, or I could read it.
Sure,
so,
I see it. I see it there.
Okay,
yeah, in fact, I'm really glad you asked that question. I assume this is a question about the creek fire. I'm doing research in that very area right now. I have a study in peer review. I've just submitted the revision about a week and a half ago. And so a couple of key things have emerged from that. There's been a lot of misinformation promoted by the Forest Service and by a state agency called CAL FIRE. First of all, the idea that 90% of the trees were dead before the creek fire occurred is not true. It was only about 11%. that has been determined by numerous studies that have looked at used satellite imagery to actually look at actual tree mortality levels. And that 11% is a pretty good thing, you know, so it was very, very low levels of tree mortality before that. You want patches of dead trees because wildlife depend on it. We've always had patches of dead trees. Now, the interesting thing is that what I found in my research, and it's similar to other studies, is that the forests that burned the hottest were not the forests with the most dead trees at the time the fire occurred. In fact, they were the forests where most of the dead trees had been removed by what the Forest Service euphemistically calls salvage logging, and oftentimes does it under the guise of fuel reduction. They're saying, well, the dead trees are fuel and it's a fire hazard, and we'll remove those trees, and that's going to reduce fuel and curb the fire. It's exactly the opposite. Those are the areas that burned the hottest in the Creek Fire. And this is a 380,000 acre fire that occurred last year in the southern Sierra Nevada. Also, the areas with commercial thinning burned more intensely than unthinned forests. And so it's very, very interesting. You know, while weather and climate were the most dominant factors, the fact is that even in the same days when the same climate weather, same fire weather was occurring, the logged areas burned more intensely than the unlogged. And all that logging was happening under the guise of fuel reduction. And a lot of it was dead tree removal. So, you know, bottom line is, you know, both live trees and dead trees, they store and they soak up and store huge amounts of moisture. When you're removing trees from the forest, you're really removing water in large part and carbon. And you're also removing shade. And the down logs retain a lot of soil moisture. They soak up a lot of soil moisture. And the more moisture they retain, the more that actually has a suppressing effect on fire. They're more like giant sponges than fuel. And so a lot of these things are really different than what we've been taught, what we've believed, or what seems intuitively obvious in the forest.
Are you saying that thinning is never a good idea?
Well, I wouldn't say never. I think that you know, if you're talking about defensible space next to homes, it's a very good idea, but not thinning the way it's practiced, you know, 19 times out of 20 out in the forest, which is just commercial logging, and it's just, you know, being done under the guise of thinning. But actual real thinning next to the home, within 100 feet of the home, is about removing lower limbs. It's about removing a lot of you know, denser clusters of seedlings and saplings. It's about basically you know, reducing accumulations of what we call duff and litter on the forest floor, twigs and pine needles and dry leaves. You know, that is very effective, and it does save homes and it saves lives, especially in combination with home hardening. But out in the wildlands, it's not doing anything good for the climate. It's not doing anything good for wildlife. The subsidies that are being used to support that out in wildlands could be better spent doing things that would actually keep people safe. And so, you know, just like we're not going to get away from fossil fuels, you know, overnight, and you know, but we need to start that shift now, and we're starting it. It's going to take time. And the same thing is true with regard to logging. It doesn't mean that we're not going to do any logging anywhere in the future, but I think we need to curb it. We need to start the process of increasing protection and start doing, shifting more towards reduced consumption wherever possible, tree-free non-wood alternatives wherever possible for paper, for building materials. There's lots of them, including hempcrete, which is, you know, made from industrial hemp, which can be grown legally now in the U.S. And it's actually carbon negative, and it's much cheaper than wood. It lasts for a very long time. It's completely fire resistant, and it is inexpensive, and it can be constructed very, very rapidly. And now it's load bearing. Didn't used to be, but now it is. So, you know, there are all kinds of alternatives out there. The problem is that all the subsidies for logging are propping up the logging industry artificially and tipping the scales against the non-wood alternatives. And that's what we need to one of the things we need to shift.
There's a question about the impact of the use of herbicides in clear cuts. And don't these chemicals act as desiccants or fire hazards? Are there any studies on this?
Yes. So the herbicides that are used both on public and private lands after clear cut logging are first of all, they're toxic. The key one is called glyphosate. It's carcinogenic. The industry claims that it breaks down pretty quickly. Well, what does pretty quickly mean? It's not that quick if you look at the data. The half-life is oftentimes several days or even weeks. And of course, if a rain comes and washes that into the streams, that ends up downstream and ends up in farmland, and that can end up in people's food. This is a big problem. And it also, as the commenter pointed out, it basically creates a lot of dry, dead grass, dry, dead shrubs, material that is readily ignitable. And so it poses a hazard to human health on multiple levels. It's a really, really dangerous thing. And so I think this is another thing that these logging subsidies on both public and private lands are propping up. It's not just the cutting of trees, it's also the herbicide spraying and the tree plantations after the trees are cut. It's subsidizing all of that.
Okay, let's see.
I had a question. Is that okay?
Go ahead, Randy.
This community was Simpson Timber, who had to deal with the Forest Service and the National Forests for what they call sustainable yield. And I'm going to oversimplify it, I'm sure, because I was not directly involved. But the understanding is they would cut some areas and they would try to stagger it, but they would cut it and then they would replant, put in nutrients and all of that. My question is, I've heard one theory: when you do something like that, as the tree matures, and I'm using the technical term here, as the tree matures, the amount of carbon it's sucking out of the air, the rate of suckage slows down. And if you put in young trees as they're growing, they suck in a lot of carbon, which is an offset or more than an offset, at least according to theory. Jeff, just wondering what you thought about that.
Yeah, thank you. This is a really important question because there's a lot of misinformation from the logging industry about that. There's two things they don't tell the public when they try to imply that a younger forest sequesters carbon more or better than an older forest. First of all, they don't talk about all the carbon emitted when they cut the mature forest before they planted the young forest. They don't talk about the fact that most of that carbon is now in the atmosphere and only a small portion is in a lumber product somewhere. So that's first key thing. Second of all, when the logging industry is talking about sequestration of young trees, they're actually being a little misleading there, because what they're talking about is basically the proportional growth of a seedling relative to the previous year. So a seedling can double its carbon year over year. Wow, that sounds really impressive. A mature forest won't double its carbon year over year, but when a seedling doubles its carbon, it's a tiny, tiny amount of carbon, of course. And that's the key thing, is that they're not dealing in absolute terms. A mature forest will continue to sequester large amounts in absolute terms, tons of CO2, large amounts every single year, and that increases and increases and increases, including when it becomes an old growth forest and an ancient forest. They continue to sequester large amounts of carbon. Let me just give you one example here. The General Sherman tree, the largest tree, well, one of the largest trees on the planet, by many measures, the largest tree on the planet. It's a giant sequoia in the southern Sierra Nevada. Huge tree. I think it's something like 38 feet in diameter. It's well over 200 feet tall. Enormous tree. It's over 2,000 years old. It's ancient tree. And that tree, even as large and as old as it is, it adds an amount of carbon every single year that's equivalent to a pole that's 12 inches in diameter and 50 feet tall. Now, there's no small tree you will ever find that adds that much carbon every single year. So just to give you an idea, now, if you look at the growth rings on that tree, they're so infinitesimally small, you need a microscope to see them. But because the tree is so big, just as a matter of geometry, and adding the height, it's an enormous amount of carbon. And that's what the foresters and the folks in the logging industry are not really accurately revealing to the public when they're talking about carbon sequestration.
Yeah, thanks for that information. Is there data available that shows in absolute terms the rate of suckage for a tree over its lifetime in absolute terms, so you can do those kinds of comparisons that you're talking about?
Well, there's a great paper on what is called proforestation, which is basically protecting forests so they can sequester and store more carbon, by Dr. Bill Mumma. He's a climate scientist, and a couple of his colleagues. It came out in 2019. You could search for it on Google Scholar. It's easy to find it. because they coined the term proforestation against MOOMAW, MOOMAW, 2019. And that paper has got a great discussion of this, a great synthesis of the scientific literature, and it's got a lot of scientific studies cited in it. So I would say it would be a really good jumping off point.
Thanks, I really appreciate it.
Sure.
Okay.
There's some more questions in the chat.
I'm trying to, what do you think about controlled burns?
Yeah, great question. So, there's a time and place for controlled burns, also known as prescribed fire. I think that probably the best place for that is after the home hardening and defensible space work has been done to create fire-safe communities. After that's been properly done, I think prescribed burning can create an additional narrow buffer around that community. You do it during early fire season. Early in the season, so it's basically guaranteed to burn at very, very low intensity and just barely creep along. It can provide an additional buffer against wildfires for a community, a narrow little buffer. But out in the wildlands, the problem with prescribed burning is that it doesn't mimic natural mixed intensity wildfire, because the wildlife species that evolved to depend on post-fire habitat, and there are many, many, many of them. Some like low intensity fire areas, some like moderate intensity fire areas where you have a mix of live and dead trees, and some like it hot, where the fire kills most or all of the trees, including in large patches. Some are adapted to depend on snag forest habitat, including actually a surprisingly large percentage of the species in the forest. Bear in mind, mixed intensity fire goes back tens of millions of years in evolutionary history in the forests of this planet. So this is deep evolutionary history. Prescribed fire doesn't mimic that. And so if we try to apply prescribed fire across the landscape based on this idea that somehow that's going to stop mixed intensity wildfires, first of all, it doesn't stop mixed intensity wildfires. It can temporarily modify fire behavior, but it won't stop them. But if you do manage to reduce or stop a high intensity fire, you could actually further threaten a lot of native wildlife species, many of which have become very rare and are imperiled because of fire suppression and post-fire logging. And those species need that snag forest habitat. So I think for me, the point is that fire around the forest is not doing bad stuff. It's doing important ecologically beneficial work, including in those patches that burn hot and kill most or all the trees. Where the threat is at the community level. And that's where we really need to focus. We need to keep the carbon in the ground. We need to keep the carbon in the forest to the greatest extent possible. Again, it doesn't mean that the logging industry will stop tomorrow, but it does mean we need to begin a conversation about a shift that will start away from wood consumption and to reduce wood consumption and increase forest protections.
I had a question earlier in the chat than that last question. So would you mind if I just answer my?
Yes, please do that. Please do that,
okay.
Dan.
So, you might have, Dr. Hansen brought this up, so I missed it, but I want to kind of hit in on the head about the climate change piece here. And my question is, what roles, if any, do drought and warmer temperatures in the West have on the risks of wildfires in forests that are being left alone, i.e. not being subjected to logging and thinning, and I may add prescribed burning of the type that you were saying is inappropriate? Can you comment on that?
Sure. So the bigger fire years tend to occur during drought years, especially big drought years. 2020 was a significant drought year, both in California and also in the Pacific Northwest, especially Oregon. We had some big fires. 2021, big drought year. And that's true historically as well. The big fires in the 1800s were in significant drought years. And if you get that combination of a significant drought year, and then you have an ignition from lightning, for example, and hot, dry, windy conditions, you're going to get a big fire, and you're going to get significant high intensity fire effects. That's been going on for millions of years. Now, because temperatures continue to go up because of climate change, because of human activities, that's going to play a role, because higher temperatures do tend to mean more fire. Now, not always, because in some areas we're getting warmer and wetter conditions, especially summer precipitation. In other areas, we're getting hotter and drier conditions. They can mean different things in terms of wildland fire. But certainly where you have drought conditions combined with hot, dry, windy weather and ignitions, you're going to get more fires, as we're certainly seeing that this year. Now, I will say this, all things being equal, given that context, denser forests that have little or no logging tend to burn at lower intensities on average when wildland fire occurs. Whereas logged areas, not only are you killing and removing many of the trees through logging in the first place before the fire ever gets there, but they're often burning more intensely and killing more trees when the fire occurs. So logging is not a fire management solution. It's quite the opposite. It's actually, for example, just to give you one example, commercial thinning, thinning and burning, prescribed burning. You know, it's this idea that a lot of people are talking about, a lot of politicians are talking about it. We'll do thinning and prescribed burning, and that'll stop these wildfires. Well, what they're not telling people is, first of all, it's not stopping wildfires, and those thinned and burned areas often burn more intensely, as I found in my creek fire results. Others have found the same. Not always, there are exceptions, but they often burn more intensely. But here's what's consistently true. Even if that thinned and prescribed burned area burns at somewhat lower intensity, which can happen sometimes, even if that happens, the thinning and burning emits 3 times more carbon into the atmosphere than wildfire alone. And there's a great paper on this by Campbell et al. From 2012 that works out the math on this and has the citations. And part of that is just because, you know, like I said, tree carbon, there's very little tree carbon that's consumed, even in a really big, intense wildfire. Whereas, you know, of course, thinning, even if it's a relatively light touch thinning operation, you're at least going to remove 10 or 15, 20% of the carbon from the forest. Oftentimes it's over 50% in thinning operations. And most of that goes into the atmosphere. Whereas, you know, big wildfire, 1 or 2% of the carbon in those trees goes into the atmosphere. That's about it.
So, and one other question here, the problem also seems to be air quality for people. So where is the balance?
Well, that's a great question. You know, there's some difficult truths here. You know, we have altered the climate. We continue to alter the climate. We need to take bold steps to reverse that. And it has to be more than getting away from fossil fuels. That's necessary. It's not sufficient. We also have to substantially increase protection for natural ecosystems, especially forests, but also wetlands, woodlands, grasslands, shrublands, anything that can pull more carbon out of the atmosphere. Now, what it means is, because we are in this situation and because we have warmer conditions and oftentimes exacerbated drought cycles, we're probably going to have more fire for the foreseeable future. And that's going to mean a certain amount of smoke and particulates. I think the conversation needs to be about adaptation, both for communities, protecting them from wildfire, but also in terms of what we can do to protect people in sensitive groups from smoke, especially people who have asthma, smoke filters, community shelters, a lot of things that we can do where we can direct resources toward that. We are not doing that right now, but we should. We should take those logging subsidies and redirect them towards smoke filters for communities that need that financially, and for households where you have 1 or more people who are in a vulnerable condition, especially asthma. That's where I think the conversation needs to go. But I will say this, what we cannot do is think that prescribed burning as a landscape scale practice is going to stop wildfires and somehow reduce smoke. And just let me explain why. Most of the carbon emissions and most of the particulate emissions in a fire come from the consumption of duff and litter on the forest floor. And duff and litter is just, you know, small twigs and little branches and pine needles and dry leaves. That's duff and litter. It's not the soil, it's above the soil. And interestingly, what the science shows is, you know, again, because very little tree carbon is actually consumed, so mostly that's coming from duff and litter. You get about 70% of the same consumption of duff and litter in a low intensity fire as you do in a high intensity fire. So the level of carbon and particulate emissions in a low intensity surface fire, like prescribed burning, is not that different from a high intensity crown fire. It is lower, but not much lower, only very slightly lower. Problem is that if you're trying to prevent a moderate or high intensity wildfire at some point in the future, you're going to have to burn every 4, 5, 6, maybe at most 8 or 9 years, because that material, the twigs, the seedlings and saplings, the leaves accumulate, they reaccumulate on the forest floor very, very quickly, sometimes in as little as 2 or 3 years or less. Sometimes it takes a little bit longer, but basically every time you do that, you're consuming that duff and litter, putting it into the atmosphere, you're putting those particulates into communities. you're killing 5 to 10% of the trees every time you do that prescribed burn. And so just doing the math on this, if you're doing this every 5 to 10 years, you're going to massively increase smoke, particulates, and tree mortality. And you're going to be having that impact all year round because they're doing prescribed burning all the way from, pretty much late winter all the way into late fall. There's maybe only 1.5 months out of the year when they're not doing prescribed burning. Pretty much January, at least in my neck of the woods, that's the only month they don't do prescribed burning. And even still, the wildfire will still burn through it. Look at the bootleg fire that burned in Southern Oregon earlier this year. Big fire, over 400,000 acres. There was a huge prescribed burn that was done just months earlier. Burn right through it, burn right around it. So, that's really not the way to go. But again, it can be a community protection, narrow additional buffer for communities.
Okay, there's a very long question here. I'm going to read it. Doesn't prescribed fire mimic how the indigenous peoples of the Sierra Nevada successfully manage the forest for hundreds of thousands of years? And if we are able to implement prescribed fire on a large scale, reducing fire hazard when a potentially large fire comes through, won't that reduce the risk of an out of control fire that starts in wildlands, growing quickly and encroaching on communities like the Caldor or the South Lake Tahoe?
Yeah, excuse me. Thanks for the question. So this is a really important issue. What the science is telling us, both Western science and also traditional ecological knowledge passed down generation to generation by Native Americans and Native American scholars, it's all cumulatively telling us that historically, before colonization, before modern fire suppression and logging policies began, we had a lot more mixed intensity wildfire from lightning strikes and a lot more Native American cultural burning. Both were much more prevalent than they are currently. Both have been suppressed, both have been marginalized. Administrative and political and other hurdles have been placed to further suppress both of them. And I believe, and many others believe, that those hurdles and barriers should be reduced with regard to both. Now, having said that, what that means is that one never precluded the other. You always had a mix of cultural burning and wildland fire. And then, of course, for many thousands of years and then millions of years before the first humans arrived in North America, we simply just had wildland fire from lightning strikes. This has been going on for a very, very long time. The one thing that's key about this is that in those big drought years and those hot, dry, windy conditions, going back many hundreds, many thousands of years, you still had really big fire years and really big fires with really large high intensity fire patches. In fact, a lot more than we have now in the era of fire suppression. So it's not a matter of using prescribed fire to stop wildfires. Also, it's really important to understand that prescribed fire is not the same as Native American cultural burning. It's different. You cannot equate one with the other. Native American cultural burning, has been practiced for thousands of years, for lots of reasons that are important to tribes in different locations for different reasons and for different tribes. And that traditional ecological knowledge, of course, is something that has been passed down from generation to generation in those tribes. But prescribed fire is an administrative practice. It's really about fire suppression, and I think it's just it's not really appropriate to try to shoehorn that into the traditional Native American practices that were oftentimes more about, according to Native American scholars, burning in a particular location for a particular food source or a particular game animal or particular material for baskets and lots of different purposes. Whereas, prescribed fire from non-Indigenous agencies is much more about trying to suppress natural wildfires. So I think, we just need to have a candid conversation about the distinctions between these things, but also recognize that there's a lot of common cause in my view, between Native American cultural burning, which has been suppressed and marginalized, and mixed intensity lightning fires, which have been suppressed and marginalized. We need more of both.
And who should we trust in the age of misinformation?
Well, that's a wonderful question. Thank you. First of all, please read my book, Smokescreen, because I talk about that a lot in the book. It's a running theme throughout the book. And I guess the bottom line is this, is that, look, every person's an individual and they're affected in varying ways by, political and economic, forces. some more, some not as much. But there is a consistent pattern, a troubling pattern, where scientists who are funded by the logging industry, either directly by logging industry trade associations, which is common out there, or by agencies that are involved in commercial logging, such as the U.S. Forest Service, which is really just essentially part of the logging industry. Scientists who are funded by these logging entities tend to produce reports and studies that promote logging. And they oftentimes have serious methodological problems that independent scientists like myself and hundreds of others look at and say, oh my gosh, that's a serious problem. And then we publish research saying, let's fix that methodological error. And it turns out that, that logging project isn't so great for biodiversity, isn't so great for the climate, isn't so great as a fire management tactic. And this is what independent scientists have been doing for many, many years. And oftentimes at the risk of getting attacked professionally and personally by scientists funded by the Forest Service or by logging industry trade groups. I've certainly experienced that myself. Now, interestingly and sort of troublingly, and this is something to keep in mind, is that a lot of the scientists who are funded by the logging industry, both by trade associations and by the Forest Service, are university scientists. And rarely do they mention that funding source when they're talking to reporters or environmental NGOs or community interest groups or politicians. So I would just say, just like it's important to have a conversation. Like I saw someone posted, the Open Secrets website about campaign contributions from the logging industry to politicians. That's really important. It's important to have that conversation with our elected officials and say, please stop taking money from the logging industry and please support forest protection. I think we need to have that same conversation with regard to a lot of scientists out there.
Yeah, I guess the old adage is right, follow the money.
That's right.
So we're looking at the Sequoia forest fire right now and the Sherman tree, and I noticed that they're wrapping it. They're wrapping it, and they're also talking about sweeping the floor.
Yeah.
Can you talk on this, speak on that?
Sure. Okay, so they're doing all kinds of stuff that's deeply misguided and unhelpful there. So a couple of things to know. These big old giant sequoias, their bark is 2 feet thick. It is insulation like you can't even imagine. They do not need to be wrapped with aluminum. Their insulation is a tremendous, profound barrier from fire. If a big old giant sequoia is going to die in a wildfire, which does not happen very often, and I'll talk about that in a minute. It does happen, and it's natural. But if it's going to happen because the fire happened to burn much hotter in that particular area because you had really hot, dry, windy conditions, and the flames, got to the tops of the trees and killed, basically the entire crown. If a fire goes all the way to the tops of the trees, it's going to kill even a giant sequoia, which is one of the most fire-resistant trees on the planet. Again, that's natural. Crown fire has always been a natural component of giant sequoia ecosystems. But again, you don't want it to mostly burn like that. It's natural for that to be a component, a minor component, which is what's happening in recent fires. Mostly the fires are burning at low and moderate intensity. And even the smaller giant sequoias are surviving. Now, I will say this. What's missing from the conversation about giant sequoias and fire, in every single news story I have read, what is missing is the fact that giant sequoias are serotinous. And what that means is they have evolved to depend not just on fire, but on moderate and high intensity fire specifically in order to be able to effectively reproduce. You need moderate and high intensity fire that burns of sufficient heat to melt the resins in the cones and release the seeds and consume that thick duff and litter on the forest floor and create a nutrient-rich bed of mineral ash, as well as kill some trees in the canopy and create an increased sunlight. Those three factors are what are necessary for giant sequoia reproduction. It needs all three. And when that happens, the giant sequoia reproduction is extraordinary. It's off the charts, especially in those higher intensity fire patches. And this is in places where you've got groves that have not burned since the 1870s, 1880s, 1890s, in many cases until recent years, because we've been so successfully keeping natural mixed intensity wildfire out of the groves, thinking falsely that we were protecting the giant sequoias because we love them so much. But the problem is we've been loving them to death. The reason they've been slowly dying off with no reproduction, almost none, over the last 130 years is because of the lack of mixed intensity wildfire, the exclusion of mixed intensity wildfire. And because we've had a number of mixed intensity wildfires over the past 6 years in numerous giant sequoia groves, we're able to actually see what's going on there. And the results are spectacular. And in my view, deeply hopeful, because what we're seeing is 10, 20 times more giant sequoias in places that have been slowly dying off for 130 years with almost no reproduction. And yes, there's always a small percentage of giant sequoias, the mature ones, that get killed in a big fire. Not nearly as many as has been reported, by the way. It's been reported that 10 to 14% have been killed recently. That's absolutely not true. That's false information. It's probably closer to 3%, but it is a percentage. But again, you're going to get 10, 20 times more giant sequoias because of those fires. Basically a whole new stand that's going to sustain the ecosystem for another 1,000, 2,000 years.
Great. What do you say to critics who say we need more houses to address the housing shortage, which has been affected by the very high lumber prices?
Yeah. Well, I say a couple of things. I say, first of all, it doesn't mean we don't build houses, but I do think that we need to have a couple of different, we need to have a conversation with a couple of components. First of all, it was normal in the mid-20th century for a family of 4 or sometimes more to live in a house that was oftentimes 1,000 or 1,200 square feet. My wife grew up in a house that was just over 1,000 square feet. It's a 3-bedroom, 2-bath house. And she had a family of 4. The house does not feel small. It's very, very intelligently laid out, very efficient. And, not everyone needs a 4,000 square foot home for, a regular sized family. We've sort of crept in that direction over the last several decades, and it's not necessary. It's wasteful. I think we're going to need to make some changes. We're going to need to really make some purposeful decisions about reducing our consumption. And so we can build smaller homes, even if they are built out of wood, build smaller whenever possible. Also use more recycled wood, use non-wood alternatives whenever possible. I'll just give you one example of a company that's doing this. It's Hempwood US. Go on their website. They're producing with industrial hemp, structural load-bearing hemp. It's carbon negative. It's about 1/3 the price of wood. But again, they have a small market share because they're just starting, and also because they're competing against billions of dollars every year of subsidies for lumber. And if we end those subsidies, then non-wood alternatives will compete. Recycled light gauge steel is another alternative. Steel, of course, has a significant carbon footprint, but if it's recycled, that footprint comes way down. Also, as we shift more and more towards a green energy economy, that carbon footprint is going to come down too. But you're not going to be able to do anything about the carbon footprint of wood. It's really always going to stay in a certain place, pretty much where it is. Most of the carbon in any tree that's removed is going to go into the atmosphere. Very little is going to end up in a lumber product. The other thing that gets left out of the conversation is the fact that when you remove trees from the forest, you're compacting soil, damaging it with the logging equipment, and you're removing vital nutrients when you remove those trees. That reduces the carbon sequestration and storage capacity of that forest every time you go in and log it. And so the idea that, this basically just, no harm, no foul, you just remove the trees and they'll grow back, doesn't work that way. Yes, certainly forests, grow back in some fashion, but usually slower and with not as much carbon with every successive logging cycle.
There's a question I missed here. Should we be supporting Native American cultural burning strictly for their cultural value then? Might these be bad for forest health?
Yeah, I think that's exactly right. To me, I think this is a social justice issue. I think that supporting Native American cultural burning is important just for simply for the intrinsic virtue and importance of supporting and upholding Native American rights, cultural rights, because this is not just about subsistence for tribes; it also has religious significance as well. And I think this goes hand in hand with protecting Native American cultural and sacred sites, including on federal lands. Right now, Native Americans' cultural and sacred sites have no real substantive protections in most cases. There are statutes that require consultation. those are oftentimes violated, but even consultation doesn't mean that that logging or mining project that destroys the sacred site doesn't mean it's not going to happen. It just means there has to be consultation ahead of time. I think that there's a lot of common cause that non-Indigenous, NGOs and interest groups potentially have with Native American tribes on protection of cultural and sacred sites, and also rights and increased access for cultural burning.
Okay, let's see, what else do I have here? Oh, so the site that you mentioned on Hempwood, US, we'd be able to see a hemp house on that site.
Yeah, they've got
Okay.
a number of examples, photographs of different houses. They've got a photo gallery on there.
Right.
There's a bunch of links on their website, so you kind of have to noodle around on it, but you'll find all kinds of images on there about it. It's really cool. And they're not the only one, by the way. They're the only one, to my knowledge, that's producing structural load-bearing blocks at this point in time, but there will be more companies doing that in the very near future.
Are they doing that also with styrofoam?
That particular company is not. Other companies are. Some are doing styrofoam, some are using other things, because styrofoam has its own issues from a climate change standpoint, but some are using other materials that are similar to styrofoam but have a vastly lower carbon footprint. Some companies are doing what they call SIPs, structurally insulated panels. Now, there is oftentimes a component of wood in those, but it's much less than the typical stick-built house. Some companies are experimenting with structurally insulated panels that use little or no wood. So there's a lot of different things out there that are pretty exciting in terms of alternatives. But again, they're competing against an uneven playing field because they're bumping up against logging subsidies and subsidies for the wood products industry.
Can you tell us the difference between what a working forest is versus a tree farm?
Well, a tree farm is considered a working forest. So I'm not a huge fan of that term working forest, because it basically it just means logging, but it's sort of a term that creates this impression like, hey, forest, get to work. And I just don't really like the imagery. But basically that terminology, it just pretty much means any forest that is in active timber production, which of course tree farms typically are.
Great. Sherry, did you have anything else?
Well, I just want to do a quick time check for everyone. So 1:21 is our time right now. And so our wrap up will be at 1:30. I just wanted to give folks a heads up about that. And if you have a question that hasn't been addressed yet, this would be a time to either raise your hand or put it in the chat box so we can have Dr. Hansen have a chance to weigh in on these issues.
Well, I wanted to say one thing that I just love this book, but there was one thing I think that Dr. Hansen said, and he called it active hope. And he said, take action without guaranteed outcomes. And I think that might be a lesson for all of us, because we expect outcomes when we take action, but maybe there's hope in just taking action.
I think so. And I think, to me, this is a key theme of my book, Smokescreen, is that, fundamentally, I believe what the science is telling us is hopeful, is positive. If we're really paying attention to the evidence, there is a way forward here, including overcoming the climate crisis and the extinction crisis. I also believe it's a way forward that is going to create a lot more jobs ultimately, but they're going to be good jobs. They're not going to be making the world a worse place. But we're going to have to shift a lot of things. We're going to have to rethink, some of our consumption patterns. We're going to have to hold politicians accountable, and even some NGOs who are promoting, some of the wrong things. But I do think that we're going to have to accept and embrace the fact that when we're guided by principles and by our ethics and what we think is right, it can't be because we're certain we're going to win. It has to be because we're certain and we feel it's the right thing to do.
Right.
I'm sorry.
There was one question here. What about the monoculture aspect of logging? And, oh dear. And is it making logging unsustainable?
Yeah, well, I'll answer that one briefly because I know time is short. people ask me this question, occasionally, like, well, what about tree plantations? What do you do with tree plantations? And what do you do with, slash piles, logging slash piles? And my first answer is this, don't create more of them. When we clear cut a mature forest and plant an industrial tree plantation, we're basically creating an unnatural condition. It's more like a crop in a place where a natural forest was. But I will say this. So we don't want, number one, first thing is don't create more tree plantations, which means, we need to stop the clear cutting, including post-fire clear cutting. But I will say this, in places where there are tree plantations, because there are millions of acres of them across the West, best thing you can do, in my opinion, is nothing. Leave them alone. Let them accumulate more carbon over time. If they burn, they burn. They do tend to burn more intensely on average than non-tree plantations, but the difference is not as dramatic as most people think. One study found that, mature forests burned at 12% high intensity in a particular region, and tree plantations had 16% high intensity. Other studies find similar things. Sometimes it's, the difference between 20% and 30%. And so, yes, they do tend to burn more intensely, and that's just an aspect of logging. But I think that, oftentimes if these tree plantations burn, you've got, it's not the best high quality, it's not the most high quality snag forest habitat. But if you've got a bunch of 14, 16-inch diameter trees, the woodpeckers will definitely use those. They'll nest in them. They will find wood-boring beetle larvae in them. You're going to get all kinds of different species naturally growing in the understory. And what I find is that nature is passively rewilding these areas every single day, every single year, every single decade. And what we can do best is what I would call benevolent neglect. Just walk away, leave them alone. Let nature reclaim those areas, because it will and it does. And all, in my view, in my experience, when we go in and we try to manage plantations based on a lot of well-meaning, well-intended objectives, all we end up doing is pulling a lot more carbon out of them, putting it in the atmosphere, and typically degrading the habitat complexity of those areas.
We have time for a question on biomass and the Duke Energy and an incinerator. Is it likely to come to this area because we do have private ownership and there's a lot of clear cutting going on?
I hope not, but I will say, I think that one thing that it's really useful, and I'm saying this to other community groups too across the West, is it's really a good idea to have a proactive conversation about this amongst yourselves, and also with local elected officials, county supervisors, city councils, to say, listen, we want our grid to be free of forest biomass energy. If there is any forest biomass energy in the grid, try to get it out and try to prevent any expansion of forest biomass within the city or community or state, boundaries. Because once it takes hold, those biomass plants, they want to be fed. And the term they use for forests is feedstock. That's what they call forests. Feedstock, just to give you a sense of what the biomass industry thinks of our forests.
Right. Yeah. Well, living on 10 acres here, I have snag forests all around me, and we're just leaving them. We clear around the home. We do have the gutters, the gutter guards, and we have the rooftops that are fairly good as far as fire suppression. But I don't know if there's anything else we can do aside from clearing them, maybe 100 feet away to help with any kind of protection that we might need. We have a certified wood burning stove, which we don't use too often, but we do use it in the winter. But people are concerned about their property around where they live and how we can, we've got clear cuts all over this place. If you just look if you Google map us, we've got clear cuts of private property, and it's a constant thing because we have an industry here. So we need to protect ourselves.
Yeah. Well, in those clear cuts, because clear cuts, basically become tree plantations. And in your neck of the woods, those tree plantations are extraordinarily dense, typically several hundred trees per acre or more. There's also a lot of slash debris associated with that, and those will tend to burn hotter when a fire occurs. Now, fires don't happen nearly as frequently in your neck of the woods, but when they happen, they oftentimes burn pretty intensely, and more intensely in those heavily logged areas. So yeah, it's definitely a concern. I think it's a community safety issue, especially when that industrial logging is right next to a residential boundary and close to a home. And I just talking to someone this morning who wants an expert declaration from me because there's a logging company that abuts their private property, and they're leaving giant slash piles right next to the private property boundary, just a stone's throw from the house on the other side of the boundary. And that's just not right. It shouldn't happen that way. So, but again, I think that a lot of this is driven by logging subsidies, and a lot of that's happening through tax breaks. Including property tax breaks at the state level. These are state legislatures. Just about every, I think, if I'm not mistaken, it might be every state in the country that has forests, which is pretty much every state, just about. But certainly, the great majority of them have massive amounts of subsidies through state property tax breaks. That needs to change. And that's a matter of holding state lawmakers accountable. But there are also huge numbers of federal subsidies of various types. Some are tax breaks, incentives, others are just direct subsidies for logging. And right now, in my view, the biggest pressure point is those logging subsidies and those provisions in the infrastructure package and the House reconciliation bill. Are the Democrats in the House need to be held accountable, and the Democrats in the Senate need to be held accountable for those logging provisions, because make no mistake, it will massively increase carbon emissions. And we can't afford that. We just can't.
That's a good take action for us. Thank you. Our particular law went into effect in 1971 in favor of the logging industry, and it's still in effect. They pay a very, very small amount of taxes in this area.
Yeah, and that needs to change. That needs to change because a lot of the really intensive and destructive logging and the extreme kind of pace and rate and intensity of that logging is being driven by those subsidies and tax breaks. And these are subsidies and tax breaks that the rest of us don't get. It's not fair. It's not right. And maybe it made sense in 1950 or 1970 or 1980, but it doesn't make sense in a 21st century world.
Mm-hmm. And are there particular political leaders in DC who are most sympathetic to your perspective?
Sure, there are a number of progressives, especially some of the progressive Democrats in the House in various places who are sympathetic. Some are just not very knowledgeable on the issue and are not motivated one way or the other. Some are not knowledgeable and are doing the wrong thing because they've been fed a lot of misinformation by the logging industry and the Forest Service. Others are pretty wise to it, and we've worked with them and tried to educate them as best we can. The problem is that what we're not seeing right now are true leaders who are willing to really speak out for the science and for these key needed policy changes, including increased protections and getting rid of these subsidies against the Democratic Party leadership. Because right now the party leadership is still uncomfortably aligned with the logging industry. And with campaign contributions from the logging industry. Now, again, I want to be clear, that's where the leadership is. It's not where a lot of the progressives are in the Democratic Party. And so I've been saying this for a number of years. I certainly say this repeatedly in my book, Smokescreen, is that we really, really need to make common cause as much as possible with the most progressive members in the Democrats, bolster them as greatly as we can, turn out constituent pressure so they know they have support and they have the impetus to take bold political action, including where it butts heads with the Democratic Party leadership, and simultaneously hold the Democratic Party leaders accountable, including publicly, where they're doing the wrong thing. Because we have to truly be nonpartisan about this. If the Republicans mess up on the environment, we need to hold them accountable. If the Democratic leadership messes up on the environment and is proposing things that would make climate change worse, that would increase risks to communities, we need to hold them accountable.
There's our nonpartisan message for all of you out there. Thank you.
Hey, can I ask a question, or are we out of time?
I could probably do one more. I'm going to have to run after that, but I really appreciate, first of all, I really appreciate the time you've all taken to spend with me in this conversation. I appreciate all the wonderful, smart questions. This has been a great conversation, but yeah, please go ahead. If you have one more.
No, that's okay. I'll let you wrap up. I'll maybe send an email or something.
Sure. Yeah. And this goes for everybody. Feel free to reach out anytime by phone or email. Sometimes I'm in the field. It may take a few days to get back to you. Sometimes I'll get back to you right away. I get a lot of messages, so sometimes I miss them, so feel free to send it again if you don't hear from me after a couple of days. But I do really appreciate people reaching out.
Thank you so much, Dr. Hansen. It was a wonderful opportunity to hear directly from you. I'm a slow learner, but I've read your book 3 times. So
wow. Wonderful. Thank you.
So I'm taking notes the 3rd time around. So I have some like elevator speeches I can do when I'm walking about my community.
Right.
So anyway, I really want to thank you for your time today, and we'll be in touch again. So take care. Have a good afternoon.
You too. Thanks, everybody. Bye.
Thank you.
Bye.
Bye.